Hello mga ka-tribes! Welcome to Daddy Brew TV. For today's video, let us expound the t-distribution. According to the central limit theorem, the sampling distribution of a statistic, like a sample mean, will follow a normal distribution as long as the sample size is sufficiently large. Therefore, when we know the standard deviation of the population, we can compute a z-score and use the normal distribution to evaluate probabilities with the sample mean. But sample sizes are sometimes small, and often we do not know the standard deviation of the population. When either of these problems occurs, the solution is to use a different distribution, and that is the student's t-distribution. Why student's t-distribution? Let us know. The student's t-distribution is a probability distribution that is used to estimate population parameters when the sample size is small. That is, sample size is less than 30, and or when the population variance is unknown. It was developed by William Seelig Gossett in 1908. He used the pseudonym or pen name student when he published his paper which describes the distribution. That is why it is called student's t-distribution. He worked at a brewery and was interested in the problems of small samples. Example, the chemical properties of barley. In the problem he analyzed, the sample size might be as low as 3. Suppose you are about to draw a random sample of n observations from a normally distributed population. You previously learned that z is equal to sample size or sample mean minus mu over sigma over square root of n. When z or where z is the z-score, x bar is the sample mean, mu is the population mean, and sigma is the population standard deviation, and n is the sample size, have the standard normal distribution. Note that if we are standardizing a single observation, the value of n is 1. Hence, the formula becomes z is equal to x minus mu over sigma. You can use this concept to construct a confidence interval for the population mean. But in practice, you encounter a problem you don't know the value of the population standard deviation. The standard deviation for the entire population is a parameter and you don't typically know its value, so you cannot use that in your formula. If that happens, instead of using the population standard deviation, use sample standard deviation to estimate it. Instead of x bar minus mu over sigma divided by the square root of n, you may use x bar minus mu over s divided by square root of n, where s is your sample standard deviation. You must take note of the change in the formula. The quantity standard deviation is constant whose value is unknown. Therefore, we use sample standard deviation, which is a statistic that has a sampling distribution and whose value varies from sample to sample. Consequently, the quantity x bar minus mu over s divided by the square root of n will no longer have the standard normal distribution. This quantity is labeled as t because it has a t-distribution. When you are sampling a normally distributed population, the quantity t is equal to x bar minus mu over s square over the square root of n has the t-distribution with n minus 1 degrees of freedom. What does the t-distribution look like? your t distribution is going to look like the normal distribution except with greater variance. You have here a plot of standard normal distribution in black and t distribution with 3, 5, 20, and 30 degrees of freedom in red, green, violet, and blue respectively. You can see that both the z distribution and t distributions are symmetric about 0 and bell-shaped, but the t distributions have heavier tails, more area in the tails, and lower peaks. The exact shape of the t distribution depends on the degrees of freedom. The figure above tells you that as the degrees of freedom increase, the t distribution tends toward the standard normal distribution. At 30 degrees of freedom, the blue curve might look like very close to the normal curve. But if you look very closely, you would see that the t distribution still has slightly heavier tails and slightly lower peak. But if you let those degrees of freedom continue to increase, the t distribution is going to get closer and closer to the standard normal distribution. Now, let's talk about properties of t distribution. Number 1, the t distribution is symmetrical about 0. That means, if you draw a segment from the peak of the curve down to 0 or to the 0 mark on the horizontal axis, the curve is divided into 2 equal parts or areas. The t-scores on the horizontal axis will be divided also with half of the t-scores being positive and half negative. Property 2. The distribution is bell-shaped like the normal distribution but has heavier tails. That means it is more prone to producing values that fall far from the mean. The tails are set asymptotic to the horizontal axis. Each tail approaches the horizontal axis but never touches it. Number 3 properties. The mean, median, and mode of the t distribution are all equal to 0. Number 4 properties. The variance is always greater than 1. It is equal to v over v minus 2, where v is the number of degrees of freedom. As the number of degrees of freedom increases and approaches infinity, the variance approaches 1. Using the formula, if the number of degrees of freedom is 10, the variance is 10 over 10 minus 2, which is now equal to 10 over 8, or 1.25. Property number 5. As the degrees of freedom increase, the t distribution curve looks more and more like the normal distribution. With infinite degrees of freedom, t distribution is the same as the normal distribution. Property number 6. The standard deviation of the t distribution varies with the sample size. It is always greater than 1, unlike the normal distribution which has a standard deviation of 1. And property number 7. The total area under a t distribution curve is 1 or 100%. One can say that the area under the t distribution curve represents the probability or the percentage associated with specific sets of t values. So much for this. Thank you for watching. See you in my next video. Bye.